Hello everyone, let's try and solve our next problem. Call a positive integer n a 710 double if the digits of the base 7 representation of n form a base 10 number that is twice n. For example, 51 is a 710 double because its base 7 representation is 102. What is the largest 710 double? Interesting. Okay, so I guess we're just going to write down, we're going to try and come up with maybe a system of equations that correspond to this property of being a 710 double. And then well, like let's first start with like something that's a 2-digit number. Let's go. Let me think. It's probably smart to start in the base 7 representation. And then, okay, let me play around with some specific cases. I'm going to start with like an arbitrary a number that has 3 digits in its base 7 representation and see what we can say about it. So if I have a number with a base 7 representation that is 3 digits, that just means the number can be written like this. Like this is the number where the representation is ABC. But now the base 7 representation now what I need to do is take the base 7 representation and treat it as a base 10 representation. So A times 10 squared plus B times 7, B times 10 plus C, this has to equal 2 A times 7 squared plus B times 7 plus C. Was that correct or the other way around? Hold on. Like, let's see if the example that they give actually works here. So 102 in base 7, 1 times 7 squared plus 0 times 7 plus 2. This number is equal to 51, right? Like they said. Or no, or is this correct? No, this is correct, right? This is the right relation. Because now if I sub in 102 here, I get equality. Right? If I sub in 102, this becomes 51 multiplied by 2 gives me 102. So let's expand this. 100A plus 10B plus C is equal to 98A plus 14B plus 2C. So I have 2A minus 4B minus C is equal to 0. So if I want, I am of course only at the moment looking at 3-digit numbers in base 7. We'll think about larger values later. So if A is as large as possible, A is equal to 6, I'm just going to break this up into cases one by one and see if we can find a solution. So I have 12 minus 4b minus c is equal to 0. Now the largest b can be, if I still need this thing to work out, if b is equal to 3, and c is equal to 0, then we're done, right? This will work. So let's check what number this gives us. 6 times 7 squared plus 3 times 7. Okay. Let's factor out a 7. 7 times 42 plus 3. 7 times 45. $115 in base 7. This is, oh, I'm not multiplying correctly here. 28, 29, 30, 31. 315. Okay. And this seems to work, right? So, you know, the base 7 representation, n is equal to 315, which in base 10 is 600. Sorry, in base 7 is 630, and 630 is twice 315. Okay, so now this is the largest. The way I found this, right? Like this is certainly the largest 3-digit number, base 7 3-digit number. Let's figure out now if it's even possible to have a 4-digit one. So the relation, the corresponding relation here is going to be 1000A plus 100B plus 10C plus D is equal to 2 times 7 cubed A plus 7 squared B plus 7C plus D. 343, is that 7 cubed? Uh, 1000 minus 686. Okay, and we can see now that it's pretty clear that A has to be equal to 0, right? If A is equal to 1, then you know, I'll never be able to find values of B, C, and D between 0 and 6 that work, right? Clearly, like let's make this as close to 0 as possible. Plus 0 minus 24 minus 12, not even close to 0. So when I go up to the 4-digit version of this, we see that A has to be equal to 0, otherwise there's no solution. And when I wrote down the 3-digit version, I sort of, you know, I made the leftmost digit as large as possible by making it a 6, and I did find a solution. So 630, that's the base 7 representation of the number. The number itself is 315. So 315 is the largest 710 double. Yeah, this problem wasn't too bad, really. Just about actually writing down an equation which represents the probability that, or the property that is described, and then understanding that the digits A, B, and C have to be between 0 and 6. Once I have the equation that A, B, and C have to satisfy, and we're told we're trying to find the largest number, it just comes down to breaking it down in cases, right? So of course we're going to start with A is equal to 6. That's the largest possible value of the leftmost digit. If I plugged in A equals 6 here and then could not find values of B and C that make this 0, I would go down to A equals 5 and try again. But we happened to get it on the first try, so I'm pretty happy with this, 315. If I find a mistake or if I've got more to say about this one, I'll put it in the description. Thanks for watching.